When considering powering two lights with the generator while retaining switch control, several options exist. Firstly, a manual transfer switch can be installed. This involves manually switching the power source for the two designated lights to the generator when needed. The client would physically operate the switch during power outages. Secondly, a smart switch can be used to control the two lights remotely. This smart switch can be programmed to automatically switch to generator power when the main power fails. This option requires a compatible smart switch and a power source for the smart switch, such as a battery or hardwire connection. Thirdly, a relay can be implemented to control the power supply to the two lights based on the generator's status. When the generator is running, the relay will activate the circuit powering the lights, overriding the regular switch. This method requires electrical wiring and setting up the relay appropriately. Fourthly, a subpanel powered by the generator can be created, and the two lights connected to the subpanel. This ensures that the two lights will always have power when the generator is running. This option necessitates additional wiring and the installation of a separate subpanel. Several additional considerations are important to keep in mind. Determine the wattage of the generator to ensure it can adequately handle the power requirements of the two lights. Consider the location of the generator to minimize cable runs and potential power losses. Ensure that all electrical wiring and components meet relevant safety standards and building codes. Inform the client about any operational requirements such as manually activating the transfer switch or monitoring the smart switch for automatic switching. Each of these options has its own advantages and disadvantages, and the best choice will depend on the specific needs and preferences of the client. The manual transfer switch is the simplest and most cost-effective option, but it requires manual intervention. The smart switch is more convenient, but it requires a compatible smart switch and a power source. The relay is a more complex option, but it can be automated. The subpanel is the most reliable option, but it requires additional wiring and installation. When selecting an option, it is important to consider the client's budget, their technical expertise, and their tolerance for manual intervention. It is also important to ensure that the chosen option meets all relevant safety standards and building codes. If a manual transfer switch is chosen, ensure it is properly rated for the voltage and amperage of the circuit. A typical residential circuit is either 120 volts or 240 volts. The amperage will depend on the size of the circuit breaker, which is typically 15 amps or 20 amps for lighting circuits. The transfer switch should be rated for at least the voltage and amperage of the circuit. If a smart switch is chosen, make sure it is compatible with the generator. Some smart switches require a neutral wire, while others do not. Check the generator's specifications to see if it provides a neutral connection. It is also important to choose a smart switch that is rated for outdoor use if the generator is located outdoors. If a relay is chosen, select a relay that is rated for the voltage and amperage of the circuit. The relay should also be rated for the type of load it will be switching, which in this case is a lighting load. Relays come in different configurations such as normally open and normally closed. Choose the configuration that is appropriate for the application. If a subpanel is chosen, it is important to size the subpanel appropriately for the load. The subpanel should have enough circuit breakers to accommodate the two lights and any other loads that will be powered by the generator. It is also important to choose a subpanel that is rated for outdoor use if the generator is located outdoors. When installing any of these options, it is important to follow all relevant safety precautions. Disconnect the power before working on any electrical wiring. Wear appropriate personal protective equipment, such as safety glasses and gloves. If unsure about any aspect of the installation, consult with a qualified electrician. Proper grounding is essential for safety. Ensure that the generator, transfer switch, smart switch, relay, or subpanel are properly grounded according to the National Electrical Code NEC. Grounding helps to protect against electrical shock and prevents damage to equipment. When running wiring, use the correct size and type of wire for the application. The wire size should be based on the amperage of the circuit and the length of the wire run. The wire type should be appropriate for the environment in which it will be installed. Use conduit to protect wiring that is exposed to physical damage. Conduit is a rigid or flexible tube that protects wiring from damage and moisture. It is required in many locations by the NEC. All electrical connections should be made using approved methods. Use wire connectors to join wires together. Make sure the connections are tight and secure. Do not use tape to make electrical connections. All electrical work should be inspected by a qualified electrician. An inspection will ensure that the work is done properly and that it meets all relevant safety standards. It is also important to maintain the electrical system properly. Periodically inspect the wiring and components for damage. Replace any damaged components immediately. Test the generator regularly to ensure that it is working properly. Following these guidelines will help to ensure that the installation is safe and reliable. It is always best to consult with a qualified electrician if you have any questions or concerns. In summary, selecting the correct option for powering lights with a generator involves considering various factors. These factors include the budget, technical expertise, and tolerance for manual intervention and adherence to safety standards and building codes. The options include manual transfer switches, smart switches, relays, and subpanels. Each option has its own advantages and disadvantages. Choosing the most appropriate option requires careful consideration of the specific needs and circumstances of the installation. Manual transfer switches offer a simple and cost-effective solution requiring manual operation during power outages. Smart switches provide convenience through remote or automated switching, but necessitate compatible equipment and a reliable power source. Relays offer automated control based on generator status, but involve more complex wiring configurations. Subpanels ensure dedicated power from the generator, but demand additional wiring and equipment installation. Regardless of the chosen method, prioritize safety by following electrical codes, using appropriate wiring and components, and seeking professional guidance when needed. When determining the wattage of the generator, it is crucial to consider the total power consumption of the two lights, as well as any other appliances or devices that will be powered by the generator simultaneously. Overloading the generator can lead to damage and potential safety hazards. Consult the manufacturer's specifications for the generator's maximum wattage rating and ensure that the total load does not exceed this limit. The location of the generator plays a significant role in the efficiency and safety of the system. Ideally, the generator should be placed in a well-ventilated area, away from flammable materials and potential sources of ignition. Minimizing the length of cable runs between the generator and the lights reduces voltage drop and power losses. The generator should be protected from the elements, either by placing it indoors or using a weatherproof enclosure. Adhering to safety standards and built-in codes is paramount throughout the installation process. Consult local regulations and the NEC for specific requirements related to wiring, grounding, and electrical connections. Use appropriately rated components and follow manufacturer's instructions for installation. Ensure that all electrical work is performed by a qualified electrician to minimize the risk of electrical shock and fire hazards. Informing the client about operational requirements is essential for ensuring proper use and maintenance of the system. Explain how to operate the chosen method, whether it involves manually switching the transfer switch, monitoring the smart switch, or maintaining the subpanel. Provide clear instructions on how to test the system and troubleshoot any issues that may arise. Emphasize the importance of regular maintenance, such as checking the generator's oil level, cleaning the air filter, and inspecting the wiring for damage. By addressing these additional considerations, you can provide the client with a safe, reliable, and user-friendly solution for powering lights with a generator while maintaining switch control. The correct sizing of the generator is crucial for reliable operation and preventing damage to the generator and connected loads. To determine the appropriate generator size, calculate the total power requirements of all devices that will be powered by the generator simultaneously. This includes the two lights, as well as any other appliances, tools, or equipment. Add up the wattage of each device to obtain the total wattage requirement. It is generally recommended to add a safety margin of 20% to 25% to account for potential fluctuations in power demand and to ensure that the generator is not operating at its maximum capacity continuously. Select a generator with a continuous wattage rating that exceeds the total wattage requirement plus the safety margin. Consider the starting wattage of certain devices, such as motors or compressors, which may require significantly more power during startup than their running wattage. The generator should be capable of providing the necessary starting wattage to avoid overloading and potential damage. Selecting the appropriate type and gauge of wiring is essential for safe and efficient power distribution. The wire gauge should be chosen based on the amperage of the circuit and the length of the wire run. Use the NEC tables to determine the minimum wire gauge required for a given amperage and distance. Choose wiring that is rated for the environmental conditions in which it will be installed, such as temperature, moisture, and exposure to sunlight. Use appropriate connectors and terminations to ensure secure and reliable electrical connections. Improper wiring can lead to voltage drop, overheating, and potential fire hazards. Grounding is a critical safety measure that protects against electrical shock and prevents damage to equipment. The grounding system should be installed in accordance with the NEC and local regulations. Connect the generator frame to a grounding electrode, such as a ground rod, using a grounding conductor of the appropriate size. Ground all metal enclosures and non-current carrying parts of the electrical system. Proper grounding provides a path for fault current to flow back to the source, tripping the circuit breaker and preventing a dangerous voltage buildup. Overcurrent protection devices such as circuit breakers or fuses are essential for protecting the electrical system from overloads and short circuits. Select overcurrent protection devices with a rating that is appropriate for the amperage of the circuit. Install overcurrent protection devices in the generator, the transfer switch, the subpanel, and any other locations where overcurrent protection is required by the NEC. Regularly inspect and test overcurrent protection devices to ensure that they are functioning properly. Labeling all electrical components and wiring is essential for safety and ease of maintenance. Clearly label the generator, the transfer switch, the subpanel, the circuit breakers, and all wiring connections. Use permanent labels that are resistant to fading and weathering. Proper labeling helps to prevent confusion and ensures that electrical work can be performed safely and efficiently. Following a checklist during the installation process helps to ensure that all steps are completed correctly and that nothing is overlooked. Create a checklist that includes all of the necessary steps, such as disconnecting the power, selecting the appropriate components, installing the wiring, grounding the system, testing the operation, and labeling the components. Use the checklist to verify that each step has been completed before moving on to the next step. Keeping detailed records of the installation is essential for future maintenance and troubleshooting. Record the type and size of the generator, the wiring gauge, the overcurrent protection device ratings, and the grounding system details. Keep copies of all permits, inspections, and warranties. Maintain a log of any maintenance or repairs that are performed. These records will be invaluable for future reference and will help to ensure that the electrical system is properly maintained. Consider the noise level of the generator when selecting a location for installation. Generators can produce significant noise, which can be disruptive to neighbors and occupants. Choose a location that is as far away as possible from living areas and other noise-sensitive areas. Consider using a generator enclosure or sound barrier to reduce the noise level. Provide adequate ventilation for the generator to prevent overheating and ensure proper combustion. Generators produce exhaust fumes that contain carbon monoxide, which is a deadly gas. Never operate a generator in an enclosed space such as a garage or basement. Ensure that the generator is located in a well-ventilated area where exhaust fumes can dissipate safely. Store fuel safely to prevent spills and fires. Store gasoline or diesel fuel in approved containers that are tightly sealed. Keep fuel away from heat sources and open flames. Never refuel a generator while it is running or hot. Clean up any fuel spills immediately. Protect the generator from the elements to prevent damage and corrosion. Cover the generator with a weatherproof enclosure when it is not in use. Inspect the generator regularly for signs of damage or corrosion. Repair or replace any damaged components immediately. Maintain the generator according to the manufacturer's instructions to ensure reliable operation and long life. Change the oil, clean the air filter, and inspect the spark plugs regularly. Store the generator properly when it is not in use. Drain the fuel tank and carburetor to prevent fuel from deteriorating and clogging the fuel system. Cover the generator with a protective cover to prevent dust and moisture from entering the engine. By following these guidelines, you can ensure that the generator is installed and operated safely and efficiently. Regular maintenance and inspections are essential for ensuring the long-term reliability and safety of the generator system.